Now, we have the case of the unknown n. Sometimes in binomial expansions, in your examination, you will have problems where the n will not be given you. That is, the exponent that sits atop the bracket of the binomial expression. It will be your responsibility to try to use some bit of algebra and the ideas that you've learned to try and work out the n. How will you deal with that? Look at this example. In the expansion of all into bracket 1 plus 2x to the power n, the coefficient of x to the power 4 is 10 times the coefficient of x squared. Find the value of the positive integer n. Let's see how we resolve that. So, in this section, like you've seen in the question that has been posed to you, we'll be looking at the case of unknown n. In your examination, one of the areas that you need to always watch out for is that there are times that we'll give you a binomial problem, and that problem will require that the n, that is the overall exponent that sits atop the bracket, will not be given. And based on the facts that are provided there, you are supposed to work out the value of the n. That's what the first question that was posed there seeks to help us to achieve. So let's just quickly delve into it, then we'll see how that's going to help us to understand. The principle is still the same. Always remember that your n, number of terms, your k respect to that, and also what the r means. The r is always one step behind the k, and it will guide you in helping to resolve all that kind of problems. Now, in this problem, we were given a binomial of the form 1 plus 2x raised to the power n. Now, the problem said that the coefficient of x to the power 4, the coefficient of x to the power 4 is 10 times. It's 10 times the coefficient of the x squared term. You get it? The coefficient of x to the power 4 is 10 times the coefficient of the x squared term. And the question says that we should find the positive value of n. Now, remember, at the very onset in our prior videos, we said that the r is always the exponent on the second part. The r is the exponent on the second part. So when you take this binomial, the 2x is what is on the second part. And the question is saying that the coefficient of x to the power 4, it clearly tells us that this 4, which is on the x, is coming from this part. The only way that an x on the second part can have an exponent of 4 is when the r is also 4. Hope you understand that. Because the x should come from the second part. The r is the exponent that sits on the second part. So if the x coming from the second part has an exponent of 4, then the r there is 4. So if the r is 4, what does that mean for your k? R is one step behind, which means that your k will be the fifth term. So which means that x to the power 4 comes from the fifth term. Hope that is clear. Again, let's look at x squared. X is coming from the second part, and x is carrying an exponent of 2. Again, the only way that your x can carry an exponent of 2 is when your r is 2. So for this part, we can say that our r is equal to 2. Our r being equal to 2 means this is our third term. So in effect, the question is trying to tell us that when you take the fifth term, the coefficient of x in the fifth term is 10 times what you get in the third term. How do we resolve that? Okay, so since we know all these things already, let's just move in there and find our fifth term. We are going to have n choose n combination, n choose 4, 2x raised to the power 4, okay? Then 1 to the power n minus 4. Let's look at the other one too. This one is also going to give us n choose 2, 2x all squared, 1 to the power n minus 2. Hope you're okay. Remember that because n is a positive integer, any positive integer minus 4, okay, obviously it's going to give you another positive integer, or even if it's negative. 1 raised to the power any of those will still give you 1. So the more important aspect we want is this. 2 to the power 4 we know is 16. So here we're going to have n choose 4 times 16 x to the power 4. This is also going to give us n choose 2 times 4 x squared. So the question says that the coefficient of x4, which we refer to as this, is 10 times the coefficient of x squared, which is this. So on the basis of that, we can connect the two expressions. We can say that n combination 4 times 16 is equal to 10 times 4 times n combination 2. Hope we are clear with that. All right, so now that we've been able to arrive at that, we are now going to see how we can resolve the relation that we have here and arrive at the value of n. Please just pay attention. Now, questions of this sort, of unknown n, guys, you always have to go back to the roots of factorial notations. The roots of factorial. So remember, if you've forgotten your rules of factorial, go back and watch the video that we did on factorial notations and just review them so that it gives you a firm grip of that. There is absolutely no way that you can go around problems that involves unknown n when you don't have clear in mind how to deal with problems that has got to do with the factorial. All right, so let's look at this here. N choose 4 times 16 is equal to 10 times that. We can resolve this into this form, okay? 10 times 4 is going to give us 40. So when we put all of that together, we can say this is going to give us n choose 4, okay, all over n choose 2, n combination 2 can be said to be 40 over 16. 40 over 16, that's clear. Okay, now what is 40 over 16? We can resolve that. We can reduce it. 4 can go into 40, 10, 16 into that, 4 into that also 4. So 10 over 4, 10 over 4, and that's the same as 5 over 2. So we can just reduce this to 5 over 2. So 5 over 2. Okay, so that's 40 over 16, 5 over 2. Now, how do we break this down? Now, let's go back to the original idea, just a bit of it. Remember in combination, all right? Let's go back to the roots. In combination, when we say n combination r, what is this implication? N combination r means n factorial all over r factorial into brackets n minus r factorial. So that is what we mean by the n combination r, or n choose r. That's it's simple meaning. So when you have n choose 4, what does that mean for n choose 4? N choose 4 will mean n factorial all over 4 factorial into brackets n minus 4 all factorial. Now note that n minus 4 factorial means that it's n minus 4 minus n minus 5 times n minus 6, and you keep on repeating as our original understanding of factorial notation helps us to know. So n choose 4 could be written as that. Hope you are clear. Now what about n choose 2? So we are saying we are dividing this by n choose 2. This n choose 2 will also be n factorial all over 2 factorial into brackets n minus 2 factorial. So that is what we mean. Now watch, this is where the algebra comes in. We just try and resolve it like how we used to do with fractions. It is division, we change it to multiplication and turn this side upside down. So this is going to give us n factorial all over 4 factorial into brackets n minus 4 factorial times. This is going to give us 2 factorial into brackets n minus 2 all factorial all over n factorial. Please don't get confused. Just go back to the basic rule of factorial or combinations. N choose r being equal to n factorial and all that. We just replace it with the values that we've been given. And we are saying that when you do that, you should have n factorial all over that divided by this, then this component also comes in. Now let's try and simplify them. Please let's pay close attention here. Here we clearly see that the n factorial can take away the n factorial. So this part here will take out that. N factorial goes away. Then you have 2 factorial divided by 4 factorial. Remember, 4 factorial means 4 times 3 times 2. Then 2 factorial means 2 times 1. So the 2 factorial can take off the 4 factorial so that it is left with what? 4 times 3. Hope you're okay with that. Now watch, this is what we mean. This is 2 factorial all over 4 factorial. I'll just break down 4 factorial to mean 4 times 3 times 2 factorial. So this will take off that, and you have 1 over 4 times 3. So this portion here, this 2 factorial can take off that, and you'll be left with 4 times 3. So what do we now get? We now have a situation where we have n minus 2 all factorial all over 12 times n minus 4 all factorial. Hope that is clear. Now, the key question is, how do you now resolve n minus 2 factorial all over n minus 4 factorial? The result of this, we will equate it to 5 over 2. And we'll be able to resolve and solve the problem easily. Hope you're okay. All right, so I'm just going to wipe out this part, okay? Then we will now see how best we can resolve the n minus 2, all that. Okay, so guys, let's just pay attention here. Okay, so let's take this part off. Like I said, if you have challenges with factorial, go back to our earlier videos on the regular course on combinations, your additional maths videos. If you've not subscribed, you can go there and also subscribe and take that course on factorial. It will help you to really understand this much more better. But I'm sure if you've got your hands, if you've got a firm grasp of what we've done, this should be easy for you to also do that. Now let's look at n minus 2 factorial over n minus 4 factorial. Now, you agree with me that n minus 2 all factorial all over 12 times. Now, let's break down the n minus 4 factorial. This okay. So let's deal with the n minus 2 factorial. This is going to give you n minus 2, okay? N minus 3, n minus 4 factorial. Because you know factorial means that you just subtract 1 and you keep multiplying by in a continuous multiplication format, okay? So you subtract 1 and you keep on multiplying, So n minus 2 times n minus 3 times n minus 4 times n minus 5, and that keeps on going. And from n minus 4 going, the whole of that could be written as n minus 4 factorial. Okay, and we are saying that the whole of that divided by 12 brackets n minus 4 all factorial. So it's very clear to us now that n minus 4 factorial can take off n minus 4 factorial. So this will take off that. And we now have our n minus 2 into bracket n minus 3 all over 12. This is equal to 5 over 2. Hope you're okay. All right, so now that we've been able to take away all the factorial notation, it is very apparent to us that we are looking at a quadratic relation. When you resolve this, you are going to get n minus 2 into bracket n minus 3 equal to, okay, 5 times 12 will give you 60. 60 divided by 2 will give us 30 here. Okay, when you resolve that into a nice quadratic, you should be able to get n squared, okay, minus 5n plus 6 is equal to 30 when you expand that. So we are going to get n squared minus 5n minus 24 equal to 0. You can use your calculators or basic quadratic factorization to prove that your n will give you a positive value of 4. A positive value of 8, sorry. So the positive value of n that will satisfy our equation for whatever, for all that will be n is equal to 8. So in fact, the binomial expression that fits into this situation where the coefficient of the x to the power 4 is 10 times the coefficient of x to the power 2 is that binomial where 1 plus 2x is raised to the power 8, as we find here. Hope it's very clear. So just take your time, just go through n, the unknown n, and always remember that it is much more of a factorial algebra. So take your time and break down the factorial, and you should be able to arrive at the answers. When you do that, you should get n equal to 8 as our answer. Question 2. The first 3 terms in the expansion, 1 plus x over p all to the power n, into bracket, in ascending powers of x are 1 plus x plus 9x squared over 20. Find the values of n and p. Okay, so in this second problem, we have been given a binomial expression. And this binomial expression is of the form 1 plus x over p raised to the power n. And the problem says that the first 3 terms, when this expansion has been done in ascending order, is 1 plus x plus 9x squared over 20. This is the first 3 terms that you will get when you have performed this particular expansion. And the question is saying that we should find the values of n and p. We should find the values of n and also the values of p. So how do we deal with such a problem? Now, it is clear that in the expression, our first term, 1 is equal to 1, so we don't have any issue. We'll just try and see how best that can be done. I'm trying to help us to lead us to the solution here. So let's look at our second term. So for the second term, we know second term, our r will be equal to 1 because r is always 1 step behind the stated term. So our r is equal to 1. What do? We are going to get n choose 1 into bracket x over p raised to the power 1. Then you're going to have 1 to the power n minus 1. Since n is positive integer, it's a positive integer, we expect that 1 raised to the power 1 of that should also give us that. So this is going to give us n over p times x. Now, when you compare it carefully with what we have, the 1 plus x, you realize that the coefficient of the x here is 1. And therefore, the n over p, which is also the coefficient when we do the expansion, should obviously also be equivalent to 1 or be equal to 1. And hence, we can say that our n over p is 1. That's the first point that we can gather from this. Now, let's look at the third term, as stated here. The third term should have our r being equal to 2. So how do we work that out? Our r equal to 2 will mean that you have n choose 2 into bracket x over p all squared into bracket 1 raised to the power n minus 2. So likewise, we are going to have our n choose 2 all over p squared multiplying x squared. Hope you're okay. So we can also then compare that the coefficient of the x squared is 9 over 20. And the coefficient of x squared here is n choose 2 over p squared. Hence, this portion, we can say our n choose 2 all over p squared should be equal to 9 over 20. Remember, like we've said, in all problems that involve unknown n, you always need to have the factorial algebra at your fingertips. If you have not really had time to go, please make sure you have time to revise it or subscribe to our video, watch the video on additional and the regular course, subscribe to it and watch a video so that you can really have it at your fingertips, how you can deal with this. All right, so now that we have these two expressions, let's now just try and put them together. Now, before we move on, let's try and break down n choose 2. Now, n choose 2 we know is n factorial all over 2 factorial into bracket n minus 2 all factorial. As we've seen previously, this can be written as n times n minus 1 times n minus 2 times n minus 3. So the whole of that could be reduced to n minus 2 all factorial all over 2 factorial into brackets n minus 2 factorial here. Okay? So this can take off that. We can cancel it. This will take off this. And that gives us a very simple solution. 2 factorial we know is 2, so we have got n minus that. And hence, we can say, let's rub this part off. Let's rub this part off. I think it's very clear for us to see where we are going here. So your factorial algebra is very necessary. Anytime you have unknown and how to work around them should not be a difficulty at all. Okay, so we can put them together. Our n choose 2 is n over n minus 1 all over 2, which is 2 factorial, which is 2. So this is going to give us n into bracket n minus 1 all over 2p squared. Okay, because you have n choose 2 all over p squared, and this is your n choose 2. And when you divide that by your p squared, it should give you that. Okay, and we are saying that this should be equal to 9 over 20. Okay, so from here we can say our n into bracket n minus 1 all over 2 should be equal to 9p squared all over 20. Note that our n over p is 1. So from here, we can even deduce without a lot of reasoning that our p is equal to n. So wherever we find p, we can replace it with n. Wherever we have n, we can replace it with p. Which means that when we find n, we've also equally found p. Okay, so this can be rewritten as n into bracket n minus 1 all over 2 is equal to 9n squared all over 20. So when we leave it in this format, then it makes it straightforward in the sense that all of the expressions that we have are all in n. It is obvious that this is going to give us something either close to a quadratic or a very simple linear equation. Now let's try and resolve that. Okay, so that takes us to our final step. We now know that p is equal to n from the resolutions that we've done. We've seen how best we can also reduce the n choose 2 to give us the functions or the values that we have in there, and it should be easier for us to also remember and keep that at the back of our minds. All right, so this 2 can take off the 20 to give you 10. Hence, you would have 10n into bracket n minus 1 is equal to 9n squared. So this gives you 10n squared minus 10n is equal to 9n squared. So when you take that here, you're going to have n squared minus 10n is equal to 0. Obviously, if you resolve this, you are going to get n minus 10 equal to 0, and our n is equal to 10. So our n is going to be the exponent that will sit atop this bracket. And in like manner, our p, which is the same as n from the relations, will also be equal to 10. Ladies and gentlemen, this is where we bring an end to the solution to the problem that we have there. So keep at the back of your mind. Keep at the back of your mind that anytime you have an unknown n problem, this problem always and always and always have got to do with factorial algebra. You always need to have the factorial algebra at your fingertips. Once you have that, it should not be difficult at all for you to be able to resolve the problem the way that we've been able to go through it. So enjoy your day. Hope to see you in our subsequent videos as we discuss the other portions. My name is Nana Kofi Bediako. It's been nice having you. In this section, we have gone through all the principal parts that you have to know with binomial expansion. I hope the videos and explanations we've given has been easy for you to understand. Keep on practicing. If you have any problem, subscribe to our channel and watch our videos and keep on doing the best that you can.